Section 6.4, Parallel Lines, Proportional Parts. Triangle proportional theorem states that if a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, then it separates these sides into segments of proportional lengths. So where you have BD is parallel to AE, that creates lengths that are proportional to each other. Converse of the triangle proportionality theorem states if a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional lengths, then the line is parallel to the third side. So they're saying that if BA over CB equals the ratio of DE over CD, then BD is parallel to AE. Alright, so let's look at some examples here. So we've got this first one. It states that you've got this triangle with two parallel lines, RT and then VU, and they're asking us to find what SU would equal. So if we're going to use one of the triangle proportional theorem, we're going to go 3 over E equals x over 12, and then we're going to solve. Okay. So we're going to cross multiply, solve, so you get 3 times 12, which equals 24, equals 8x, and x equals 3. So in the next one, we're doing the same thing. We're trying to figure out if the statement's true. So basically, we're just going to plug in what we know. We have DH equals 18, and HE equals 36. So they want to know if DG equals half of GF. Well, we're going to say, well, DH equals 1/2 HE, so we're just using what they gave us. Then 18 equals half of 36, that checks out. So that means that since this is half of the whole thing and DH is half of DE, then they are going to have proportional sides. Right. Your next example, I want you guys to take a look at. You're going to be using distance formula and slope. See what you guys can figure out, and then when you guys come back from unpausing the video, we'll go over that. Alright, example 3. Before we go into example 3, I just want to read you guys the definition of a midsegment. Segment whose endpoints are the midpoints of two sides of the triangle. Okay, so in our example here, DE is our midsegment. It intersects D, which is the midpoint of AB on your page, and E, which is the midpoint of AC. So they're asking us to find what the coordinates of D and E are. Well, if DE is a midsegment, we have to use the midpoint formula to find the ordered pairs to D and E. So in this case, we're going to say, well, D would be 0, 3, because I'm taking my ordered pairs of A and B, okay, adding up the x's, dividing by 2, and the same thing. So in the end, I get a 0, 3, and 1, negative 1. Or you can just look at the figure to the left and figure out what those ordered pairs are. The second part of this is verify that segment BC is parallel to segment DE. Alright. Well, that's easy enough. We need to see what the slope of DE is. So you have your two ordered pairs here. You find the slope by taking 1 minus 0 and negative 1 minus 3. So you get negative 1/4. We do the same thing with BC, just here. Okay, so you're going to take these two ordered pairs. You're going to go 4 minus 2, and then negative 4 minus 4. And then you're going to find that they both have the same slopes. The last part of this particular question is to say we want to verify that DE is half of BC. So this is where you're going to have to use your distance formula. You first find the distance of D to E, and then find the distance from B to C, which I have the workout there. I find that D to E is approximately the square root of 17, so a little more than 4. And then we find the distance from B to C, and that's the square root of 68, so that's a little more than 8. So if we double a little more than 4, that equals a little more than E. So therefore, that segment is half of the other segment. Alright, so we've got a few more examples and a few more definitions. The first thing we're going to do, we'll look at two corollaries. Your first corollary states that if three or more parallel lines intersect two transversals, then they cut off the transversals proportionally. Okay, so to the figure to your right here, you're going to see you have two transversals that make the X, and then you've got three lines that are parallel to each other, indicated by the arrows. The next corollary states, if three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Okay, so they're talking about that we've got these points here, that these points are going to be the same. So let's look at a couple examples. Right. Our first one gives us a few streets. Okay. So what they're saying is that if you look at Larch, Maple, and Nuthatch, you see where the 13 and the 26. I see that 13 is half of 26. So whatever X is in this particular problem has to be half or double 16. So 16 has to be half that number. So what I did here is I set up a proportion over here. I knew that 13 over 26 was 1/2, so I reduced it to make my math easier. So then I doubled my 16, and that equals X. So in this case, using corollary number 1, X is 32. So why don't you take a minute, pause the video, and take a look at the next example. Alright, so you should be back, and let's just look at this example. On here, they want us to find X and Y. So when I look at this figure, I see that there's little tick marks indicated on the figure. That means that 2x plus 2 is going to equal 3x minus 4. And then, if those two segments are equal to each other, then 8/3 y plus 7 is going to equal 5y. So I'm going to set up those two equations and then solve. So the 2x plus 2 equals 3x minus 4. I'm going to add 4 to 2 and then subtract 2x from 3x. So I get x equals 3. The next portion, I'm going to solve my 8/3 y plus 7 equals 5y. I first make the 2 and 2/3. So I'm making a mixed number from the 8/3, the improper fraction, and then I solve. I'm going to subtract my 2 and 2/3 from 5y, which I then get 2 and 1/3 y equals 7. I'm going to make this back into an improper fraction. I was just trying to make my life a little easier. You may have just left it in improper fraction or a decimal or whatever you may have done. If you made it a decimal, sometimes you have to watch out, because if you have 1/3, you're not going to get the exact answer. You'll get an approximate answer. So I multiplied by the reciprocal, 3 over 7. Okay. Crossed out, cross-canceled, and I got y equals 3. So this concludes section 4.